Hello dear children, today's class we are going to discuss the fourth part of the projectile motion. Dear children, in the previous classes we discussed about what is a projectile motion, what is a projectile motion and the conditions related to it, and we also discussed the horizontal projectile motion, the inclined projectile motion and the parameters related to it. Especially in a previous class we spoke about the inclined projectile motion where a body is projected with the initial velocity u such that it makes an angle theta with the horizontal. Children, this is very important. I repeat once again here. A body is projected with the initial velocity u such that it makes an angle theta with the horizontal, so that here u cos theta is a horizontal component and u sin theta is a vertical component. And we discussed about the parameters related to it. What are those parameters? Yes, we discussed about the equation of trajectory. Dear children, what is the equation of trajectory here? The equation which gives the relation between the horizontal distance and the vertical distance covered by the projectile is called equation of trajectory. There we got y is equal to tan theta x minus g by 2u square cos square theta into x. Next we discuss time of ascent. So the time taken by the projectile to reach a maximum height is called time of ascent, that we got as a u sin theta by g. And h is equal to what here? U square sin square theta by 2g. Maximum height means the whatever the vertical. So in a vertical distance projectile has some distance, right? That we can call that maximum, where the final velocity of the vertical component is going to be 0, that is u square sin square theta by 2g. Next, t is a total time taken, I mean time of flight. The time for which projectile remains in air is called time of flight. There we got as a t is equal to 2u sin theta by g. And we got range. What is the range, dear children? The maximum horizontal distance covered by a projectile is called maximum, or I can say the range it is. So range is equal to u square sin 2 theta by g. And dear children, here don't forget that when the range is going to be maximum, when theta is equal to 45 degrees. Is the point clear? Fine. And at any point, let us say v is a instantaneous velocity. Then this formula v is equal to square root of u square plus g square t square minus 2u gt sin theta. So this is the magnitude of the instantaneous velocity, and the direction is beta is equal to tan inverse u sin theta minus gt by u cos theta. And you may get one doubt. So then what is the specialty of today's class? Dear children, a small difference will be there, but it makes a lot. So if you cannot notice this, definitely, so there are chances to commit a mistakes. So in today's class also, I am going to talk about the inclined projectile motion only, but small difference is there. What is that small difference? Let us see that here. So in this case, just try to understand here. A projectile is fired with an initial velocity of u. Then you may get a one doubt. Yes, sir, what makes a difference? Here also it is fired with an initial velocity u, and here also. But here it makes an angle theta with a horizontal. But in this case, it makes an angle theta with the vertical. Very important. Very important. So here projectile is fired with an initial velocity u such that it makes an angle theta with the vertical. Then what makes the difference? You may get one doubt. Okay sir, such a small things, what happens? Let us see that here. So here horizontal component will become u sin theta, whereas vertical component will become u cos theta. Very important. But in previous case horizontal component is u cos theta, vertical component is u sin theta. Means here these horizontal and vertical components are getting exchanged. So in this case where projectile is fired with an initial velocity u, which makes angle theta with the vertical, in this case u sin theta is going to be a vertical component, u sin theta is going to be a horizontal component, and a u cos theta is a vertical component. Which means what here? In the previous case, u cos theta is a constant. U cos theta is a constant. But here now U sin theta is a uniform. That is a constant, uniform, whereas U cos theta is a non-uniform. Non-uniform. Means in this almost all parameters will get affected. Let us see. First, what is a trajectory of equation? So y is equal to, children, in this case try to understand. As I said here, sin theta is going to be a cos theta, and cos theta is going to be sin theta. Tan theta is going to be cot theta. This is very important. You need to understand this. Here it is make an angle theta with the horizontal, but here it is make an angle theta with the vertical. Then horizontal component, vertical component completely gets exchanged. Means sin theta will become cos theta will become sin theta, tan theta will become cot theta. Now let us see. Of course, you can remember this. You can take these parameters as a reference to write parameters in this case. So y is equal to cot theta into x minus g by 2u square sin square theta into x square. Look at here. Means in the place of tan theta, we will get a cot theta. In the place of cos theta, we will get a sin theta. That is what you should understand. Okay, fine. And the second one, time of ascent. Time of ascent is going to be a u cos theta by g. Means here is u sin theta by g. This will become u cos theta by g. Next, third one, what is that here? Maximum height. Maximum height is equal to u square cos square theta by 2g. Okay, now previously it was sin square theta, it will become cos square theta. And here is fourth one, time of flight. This is going to be 2u cos theta by g. Previously it was 2u sin theta by g. Okay, okay, we will come to range later. And here is what we can say sixth one. Fifth one I will come back. Okay, instantaneous velocity at any point, let us say it is a horizontal component and this will be a vertical component, such that it is a instantaneous velocity makes an angle beta. Okay, so v is equal to, this will be u square plus g square t square minus 2u gt sin theta. In the place of cos theta, we will get a sin theta. Yeah. Now, whatever I missed is fifth one is, of course, even we have to see the angle beta. So, this beta, the direction is very important. So, this is tan inverse u cos theta minus gt by u sin theta. U sin, you can here see here. So, sin theta, anyhow, tan will be the actual direction will take, right? Okay, so that won't get exchanged only in this one. Okay, and cos theta will become sin theta. And the range, the fifth one, range, very important. When I say range, now if you know many students will follow this, and by default they can write range is equal to u square sin theta by g. No, that is wrong. So this is going to be u square sin 2 theta by g. Sin theta by g. So this is very important. Which means what here? Which very important. Look at here. So here in this case, range is equal to u square sin theta by g only. Here also range is equal to u square sin theta by g only. Means other than range, all parameters will get changed. All parameters will get changed. Only range remains constant. When a projectile is projected, when a projectile is fired with an initial velocity u, such that it makes same angle with the horizontal and as well as with the vertical. In that case I'm talking. So range will be same, that is u square sin theta by g only. For example, here this angle and this angle must be same. Here in this case initial velocity, in this case initial velocity must be same. In that case range remains same and other factors will get changed. So children, this is a today's discussion. Of course, it might be a video is very small, but very informative. Very informative. Seems to be same. Two situations seems to be same, but try to understand. Here the projectile is fired such that it makes an angle theta with the horizontal. But whereas here projectile is fired such that it makes angle theta with the vertical. So with that, horizontal and vertical components will get exchanged. Hence, all parameters will get affected except range. Are these clear? Is very important. Okay, dear children. Okay, so in the next class, we will be talking about the projectile motion. Means when a projectile is fired from an inclined plane. See, inclined projectile motion is different. Inclined projectile motion means what? Of course, the projectile is on the horizontal only. It is fired as it makes an angle theta with horizontal. But next class, we are going to talk about the projectile is fired on the inclined plane. Okay, children. Thank you so much. All the very best.